morning, my name is Dennis Chin, UR14CS319, and I'm here to do my 9th experiment of Unix Lab. This deals with the inter-process communication using pipes, and we have two aims, using name pipe and unnamed pipe. Name pipe is basically an extension of the traditional pipe concept of Unix and Unix-like systems, and is one of the methods of inter-process communication. Then unnamed pipe is a simple first in first out communication channel that may be used for the one-way inter-process communication. An implementation is often integrated into the operating system's file I/O subsystem. So let's take a look at our program here. First we have our header files followed by int void. I've given two variables, fd array and bytes I and D. I've given child process ID and string array of 100. RB100 is also there. Next we have FID, print pipe created. If the ID is equal to 0, we print that the pipe is created, and if it's not equal to 0, we print that the pipe is not created. We print the process ID in the next statement, and then we enter the string. We input that string from the user and then enter it to our s value, and this value is being entered into our into our string length. The string length is calculated and incremented by 1, and if the child PID process ID is equal to 0, then we call a fork system call. If not, we read the n bytes and the word read of size, and you find the size of RB, and you enter that as a parameter into n bytes. Next we have and if loop RBI is equal to A, then we pipe that into RB of I is equal to E, and this would basically RB of I would be to upper RB of I array value, and then at last we print that the received string would be equal to RB. Lastly, we return 0 as our last step. Name pipes are also called, again, it's also called first in first out. They have names and exist as special files within this file system. They are created till they are removed with rm or unlink. So when we execute this, we have the following. So the string I'll enter would be Nix, and it says the received string was that. Okay, and now moving on to our next segment, we have our write.c code. Again, we include our header files, and then inside the main we have a few other variables, followed by the buffer array of size 100. ID is equal to mk node my pipe. We have three parameters: my pipe 0755 and IFO. This will create the node, and if ID is equal to 0, then we print that the pipe has been created, else the pipe not created. Enter the string. We input that string from the user, and then FD is equal to open my pipe and read and write. Lastly, we write the parameters of FD buffer or the string length into the FD, and then we close FD. In order to read, we have the following code here. We have our header files. We have variables FD, character buffer 100, and to read we open our file first in my pipe or read write. Int bytes is equal to read FD buffer size, and at last we give the value of our buffer value. As I said before, like when we execute this, when we compile this code, we're told to enter the string, and once we compile that, we enter that. It says the pipe has been created. I've entered my second string, and that has been created as well. And then lastly, when I run my read code for read, we have a buffer in the pipe that is named Dennis. So that's it for our ninth experiment. Thank you.